So today we're going to cover another group of chapters, the last group of chapters we have in our document, our textbook. So let me start sharing that book chapters. And the book chapters are the final groups, started with the stepper motor and ended with PWM. So 4 chapters. So let's go right into it. The stepper motors, these are generally you can salvage a stepper motor from various electrical devices like a floppy disk drive. If you have an old computer, have a floppy drive, and that floppy drive is controlled by a stepper motor. So in this case, it's has 1, 2, 3, 4, 5 wires. So this is called a unipolar. 5 connections. So those are the 1, 2, 3, 4 coil, L1, L2, L3, and L4 with a common ground, which is black. So, and then there's energizing diagrams, how you energize. So this is a typical drive, electrical circuit to drive the 4 coil. And the other side will connect to a computer. So that's the schematic. And to drive this thing, the most commonly used driver can be a transistor. So that's a transistor. This transistor is called the Darlington transistor. They call it Darlington because it has 2 transistors connected together to increase the current gain. So if Q1 is 100, Q2 is 50, combined together it will be 100 multiplied 50. It will be 5,000. So 1 milliamp goes here, 1 milliamp multiplied 5,000, we will have a 5 amp goes through the coil. So 1 milliamp here, 5 amp here, because 50 multiply 50 multiply 100. So that's 5,000. So that's Darlington. That's one way to drive those each coil. We can also run the stepper motor half step. So if the stepper motor, every step is 7 degrees, we can actually control the energized coil differently. So this is one way, this is a full step energizing. So full coil, we just turn A on, turn B on and off, turn C on and off, turn D on and off. That's a full step drive. So that's 1 step, 2nd step, 3rd, 4th, 5th step, 6th step. So every time the ABC changes, you follow this sequence. You don't skip a sequence. That's your causing problem. So A have to be exactly like what we plotted over here. So does B and C and D. So that's the exact pattern. We must follow this pattern. Once we follow this pattern religiously, the stepper motor will rotate forward or backward. Every step, for example, will be 7 degrees. But we can also drive the stepper motor half step. How do we drive a half step? They say the ABCDs are provided to drive the motor half step. So from here to here, half step. So instead of 7 degrees, we have 3.5 degrees forward or backward, and another 3.5 degrees. So half step. So a stepper motor was designed to run one step at a time by computer. but we can run half step. Not only we can run half step, we can also run this motor, what we call baby step, baby stepping. Baby step. So that means a quarter of a step or 1/16th of a step. And then the ABCDs have different patterns also to drive baby step. So baby stepping is another way. Almost we can control the stepper motor in greater detail. Rotate instead of 7 degree, we can run 1/4 or 1/8 of a full step, or 1/16th, or 1/128th of the steps forward or backward, if we do have that kind of a requirement. So baby stepping. And every different mode require different patterns on those 4 coil ABCD. So you have to go different patterns. That's mode number 2, mode number 1, and there's a mode number 3 also called baby. And the author provide a software example, use Raspberry Pi. So it would be great if you have an old floppy drive or old printer. I found out that in the old printers, if you have a printer or your neighbor threw away an old printer, you can just grab it for free. I actually gave out a lot of printers. I have many printers. Previous semesters, some students said, "I don't have a printer." I gave you. I have tons of those, so for free. That's our first topic. The second topic is the H drive. That is the most commonly used drive for DC motor. So this is H drive is controlling a DC motor. It got name H because it looks just like H. You see, you have 2 transistors on one side, another 2 transistors on the other side, and you have a horizontal link, which is the motor. So it looks like a letter H. That's how it got its name, H drive. So H drive is used very common. So that's the H drive 1, 2, and 3. How about those diodes? Those diodes are just for protections. When we want to shut off the motor is an inductive device. By being inductive, that means that motor has energy. Even though you shut it off, if those energy there's no place to release, it will create a spark or damage the transistors. So in order to protect those transistors, we put those diodes. So provide a return path for those energy. So that's another thing. All those H drives, all those transistors must have a diode in reverse for protection. And those H drives, of course, you can always build one yourself, no problem. But generally, the author have an example here. You buy the H drive. That's inexpensive, actually cheaper to buy a pre-made H drive than to make it yourself. So the author provides one example over here, and on my camera I have another example. That's the H drive right in the middle. This thing will talk to a computer on one side. That's the computer connections. Over here, those are the computer connecting wires, and then the power and the motor are connected. Those are the power connections and the motor connections. So a motor can be the RPM, the DC motor. How do we control the RPM of a DC motor? Using H drive. One quick answer is this last chapter called the PWM. PWM combined with H drive will control the RPM of a DC motor. So basically, when you have low RPM, you do this. You do this. You need a high RPM, you do this. Right? So that will be low RPM and high RPM. What's the difference? That's the on position, that's off position. When you want to drive this motor in low RPM, you on for very quick and then off for very long time. And usually you're switching them tens of thousands or hundreds of thousands hertz. So you switch them really fast. You are not turning it on 1 second, off 3 seconds. That will cause a problem for your mechanical drive. You do it tens of thousands, hundreds of thousands of times every second. That will smooth out, became RPM, varying RPM. So this is a H drive, and using H drive to control a DC motor, where you can control the RPM of the DC motor. That's very common used for control. What is the advantage of PWM? The advantage of PWM over the traditional DC control. The traditional DC control is like this. Goes from 0 to 10 watts. That will also control the RPM. You have a variable voltage. But this is called the switching. By being switching, it's more efficient. So efficiency can be larger than 90% efficiency. That means for every 9 watts goes to the motor, there's only 1 watt wasted on the electrical drives. So the electrical drives will be relatively cool compared with the other drives will be very hot. So switching drive is all about efficiency. So we are turning this thing on and off using PWM. So that is a H drive, and we can program it with a computer, and we can do a DC motor. Then how about another type of stepper motor called a bipolar? The bipolar stepper motor is has only 4 wires like this. This is a bipolar. So the bipolar stepper motor has a 2 coil only, and this 2 coil has 4 connections. So that's called a bipolar. The bipolar stepper motor need a 2H drive. So you need a 2H drive. So that's a H drive between 2 and C. That's a second H drive between number 13 and number 14. 2 and 3 output will be a H drive, another H drive for L2. So to drive a bipolar stepper motor, in compared with the previous one, it's called a unipolar. To drive a bipolar, you need a 2H drive. That's what it is. I have a bipolar. So right here, I have this actually came out of a printer. So I just opened up the printer. There are so many treasures inside that printer. The first off, there's a power supply, excellent power supply, switching power supply. You want to grab that part. Second, there are at least 5-6 motors. Some are DC motors like this. These are DC motors. Some are stepper motors. This is a bipolar stepper motor. If you look at the connections, it has only 4 wires. And this bipolar stepper motor is driven by 2 H bridges. So these are the 2 H bridge right here, 2 H bridge. And there's another 2 H bridge on the other side. So that implies not only this drive can drive one stepper motor, bipolar, can drive another stepper motor. So it can actually control 2 stepper motors. Or alternatively, 1 stepper motor, 2 DC motor. So I'm connecting this DC motor, so it can drive 2 DC motors. So or 2 DC motor, another 2 DC motor, for a total of 4 DC motors. So this is another example. This is my favorite drive, motor drive. It also has two servo drives on this side. So there's a servo drive on here, another servo drive. So that's a servo. There are two servo connectors. So this motor drive can drive maximum 6 motors, 4 DC, 2 servo. How about cost? This one is very inexpensive. I think this costs about less than $20. So if you have a project need a H drive, it has 4 H drives and 2 servo drives. So if you have a project need a couple of H drives to drive a DC motor or bipolar stepper, use one of these. This is called Arduino motor drive. Just Google it, Arduino motor drive, and you will find this. This is my favorite. It's wonderful. This is Arduino motor drive version 1, V1 version. Many years ago, they came out a V2 version. The V2 version still driven by Arduino. That's an Arduino computer on the back. Still driven by the Arduino. The V2 version is stackable. Stackable means they can plug another drive on top of it, the first drive. So you can stack, if I remember correctly, 16 drives, up to 16. What does that mean? That means one Arduino computer can control 16 of these cards. Each card can have 6 motors. 16 multiplied 6 means how many? 100, right? 96. So you can drive 96 motors maximum by one computer. So you're really working on something really complicated, need 96 motors. And then you can use the V2 version of this motor drive. So that's our first topic, 3 chapters.
Dr. Zhang.
Yes.
What have you used with your drive?
My?
Yeah. What have you used with it for?
I'm not working on any project as a demo for the classes. Yes.
Oh, okay. But I mean, like, have you used it before though?
No, I didn't use it for anything.
Okay.
I have a project right here called the Solar Tracker.
Oh, okay.
Solar Tracker has 2 angles, so you need a 2 stepper motor or 2 DC motor. I can use 2 stepper motor to control the solar panel to follow the sun.
Oh, okay.
For example, yeah, the potential is limitless. Yes. So that's the first topic, 3 chapters, 27, 28, and 30. The last chapter is my favorite topic. So I left that favorite topic. I said one favorite topic is the node red. Chapter 29 is another of my favorite topic. What is this? This is how the Raspberry Pi or Internet of Things, IoTs. So generally, the Internet of Things is something we can connect it to Internet, right? Sensors, little things. Internet of Things. How can the Internet of Things talk to each other? That is the subject. The Internet of Things can talk to each other. How? One word, MQTT. So MQTT is how Internet of Things talk to each other. In this chapter, the author did not use MQTT. The author used this, 0MQ, 0, not QMQ, 0. So 0MQ is another alternative to MQTT. They all work perfectly. I haven't used 0MQ, but I've been using MQTT. It's simple. It's excellent. So that's why it's my favorite topic. That is assuming you have multiple Raspberry Pis or multiple smart devices in your house. So let me say, what is MQTT? MQTT is like a Twitter. It's like a Twitter for Internet of Things. So if one Internet of Things wants to talk to another Internet of Things, what did he do? He will tweet. Instead of tweet, he MQTT. So let me give you a demo for the MQTT. I felt a demo will much easier to understand than a lot of word. So let me go right into a demo, MQTT demo. I will start a terminal first. I will start my terminal, and then I will share my terminal so you will see my demo. Let me share my terminal. Okay, share. So now you see my terminal. I will SSH to my Raspberry Pi. That's the Pi sitting right in front of me. Is it dead or maybe it's dead? Oh, I typed the right address. So now I log into my Raspberry Pi. I will first have you see the instructions. So these are the instructions to get MQTT installed. For example, if you use a Twitter, what do you need? Tell me if you want to use a Twitter. You need to download a Twitter client, right?
Right.
Yes. And also, there is a Twitter server. In this case, you have to do both the server and the client yourself. Because when you tweet, the company already did the server for you. In this case, you have to do the server yourself. So this is the installation of a client and the server, and so let's do this here. So this will install the client and the server. So the first part is the server, is MQTT server called Mosquito. So you will install Mosquito. After you install the Mosquito, you have the server. But if you want the Twitter client, you have to install the client. And what is the last part? The last part is here. I found that this is obsolete. This part doesn't exist anymore. So instead of using this, you were using the following command. That is the Python package for MQTT. So if you want to program using MQTT through Python, you have to install the third package. So what do you need? You need a server, you need a client, you need a Python package. So you will install all three on your computer. And then what you can do is you can do a Python example on MQTT. So this Python example MQTT is once you install, the server will start working. So what do you want to tweet? So let's first say I want to tweet. This will be this post code. So we will say MQTT poll. That is when you want to tweet. So it's very simple. The most important part, you want to tweet, the most important part is your message. What is the message you want to tweet out? This will be the message. That's my first tweet. That's my second tweet. That's my third tweet. That's my fourth tweet. So in this program, I will tweet 4 short messages, 1, 2, 3, 4. And in between, I will wait 2 seconds. 2 seconds. I will wait 2 seconds. And where exactly is the server? This is the server. So I will tweet to this place. Suppose you are not on the same host. I'm running on the same host. If I'm not running on the same host, I have to change that to the IP address of the server. So if I say MQTT post Python, so I have to go over here. If I'm not to post a tweet to the same host, I will enter the IP address. So that will be 187.168. 168.1.187. So that will be the IP address of my server. So that implies the server can be a separate separate machine, as long as it's on the same network. So I will save it. Now, if I do the same thing, my code changes to the server I want to post to. So I can post from any computer, any Raspberry Pi. It doesn't have to be the same Pi. In this case, it's the same Pi, but that's the tweet code. After I tweet, any client can read all the 4 messages. I tweet 4 separate messages. So let's look at the tweet, the computer who want to read the tweet message. It's called MQTT LED dot Python. So what it does, it will turn the LED on pin number 11 on and off, and then turn the LED on pin number 17 on and off. So that's what it does. So the tweet message actually instruct another Pi, whoever is the client, to turn the LED on and off. So by sending out a MQTT message, I'm turning on and off LED if the client is programmed that way. So this is the client. So what it does, it will find the server. Find the server. So let me, where is the server? Server is right here. So this is the server. In this case, the server is on the same Pi. Let me change that. So I will change the MQTT-LED.Python. I will go to that local host. I will change that local host to IP address of my server. That means the client don't have to be the same computer. The client can be any computer on the same network inside your house. So I will just do the 192.168.1.187. So that will be my IP address of my server. And then I will save it. So if I do the same thing, I will find that that place has changed to the IP address of my server. Now I will do the demo. In order to do the demo, I need to open another terminal, another terminal, because I need one terminal as a server, post, one terminal to post, the other to read. Those 2 terminals can be 2 separate Pi. So in this case, we can have 3 Pis. The first Pi is the server. The second Pi is the tweeter who posts a message. The third Pi is the tweeter who reads your tweet, right? So let's assume this is the second Pi, where it will post a message. So all I need to do is like here, I will do a Python MQTT post dot Python. So I will run this program. It will send 4 tweet messages, right, to MQTT. It's not tweet message. So it's similar to tweet messages. It's MQTT messages. So I will send 4 messages to the server. It will wait 2 seconds in between. So 2 seconds. So 4 messages posted. Now, what happens is on the client side. So on the client side, I will say that will be my tweet reader, mqttled.python. No, I need a Python before Python, mqttled.python. So this program will read all 4 tweet messages, MQTT messages, and respond by turning the LED on and off. So turn the LED on. Well, I have to run the, it doesn't read the old tweet messages. So the old messages doesn't have any effect. So I have to retweet on another window. So that I will open another window, which is invisible to you, but it's visible to me. I will send the tweet message again on another window. So I will go to my Pi, I will go to the directory, I will rerun my program. And then on the window I share, you can see the response of the client. So I will retweet, I will resend the MQTT message, MQTT post. So I will rerun Python MQTT post dot Python. You see, it responded. It will turn on and off, turn the 11 on, turn 11 off. In this case, my code says there's no LED on the pin number 17. That's what it happened. I don't connect, I just have one LED. So the LED will be turned on, LED will turn off. That can be a separate Pi. So this is MQTT. MQTT is wonderful because it's a very tiny package. You can put it on almost all the computers with a Wi-Fi connection. The most popular one, Wi-Fi connection, is the $1 computer. It's called M68, 65, 85, or 86. I forgot the part number, but it's the most common $1 Wi-Fi module. It's a small computer, but has a Wi-Fi module. I have this. Inside is those $1 Wi-Fi modules. So potentially, I actually spent about 2 hours this weekend, opened it up. What happens for this Wi-Fi smart switch is a smart outlet. It's all handled by a server. I was thinking in Hong Kong because this company is their address is in Hong Kong. So if I want to turn my whatever on and off from my outlet, smart outlet, all those information actually travel to Hong Kong and then coming back, turn my device on and off. So alternatively, I can reprogram this computer with a MQTT client. Then I will control my air conditioner unit or lights or whatever using MQTT without going through the server at Hong Kong, which will have my Wi-Fi password, everything. They require something. So that's make it a closed control, MQTT. So MQTT is my favorite. To make it even better, what about my 2 favorite subjects put together? So the Node-RED actually have a MQTT module. So let me show you the Node-RED MQTT module. Let me first start the Node-RED. Node-RED start. Anybody still remember how to start Node-RED?
Is it just no red stop or start?
Do we have to sudo? Okay, I start my Node-RED. Perfect. Once Node-RED is started, let me share my web browser here. So I will have this Google web browser. Let me share that with you. Google. So now I will point my anybody remember the address for Node-RED? Let me see. 1880. Okay, 1880. So now I go to the Node-RED IDE. This is Node-RED IDE is web browser based. So right here you have MQTT in module. That will be post. You can post whatever. That's a MQTT post. That is read a MQTT. So you have so this post to a server. So this is a message, MQTT message to a server. This is a read a MQTT message from a server. And I did it last year. This year I haven't do it. That means I will using MQTT to so the Raspberry Pis can talk to each other, or this $1 Wi-Fi computer can talk to each other to talk to Raspberry Pi. So this $1 computer, you can actually buy 10 of those. You program all 10 of those, and you put it in various places around your house. And they can measure, for example, temperature, control lights, and do whatever you want to do. And then you have Raspberry Pi as an MQTT server. And so all those computers can post and can read from each other. In a way, they can communicate with each other. So that's literally is my favorite subject. That's Node-RED plus MQTT. It is wonderful because it's opened up a lot of home automation. Sky's limit. You can do so much. Especially this Node-RED has a web browser interface. So you can use your cell phone or iPad or any computer with a web browser to make your home automation. All right, that is pretty much I have for today. Any questions about the?
So this just basically just can control anything in your house, like your lights or your fans.
Yes, exactly. MQTT is how Internet of Things talk to each other.
Okay.
Yeah, cool. Because you have so many Internet of Things. You do not want all your Internet of Things talk to a server, which you never know where they are.
Oh,
When you buy all the smart devices, the first thing they want you to do is connect your device to a server outside your house.
Yeah.
Right?
Yeah.
That's something you don't want to do. So when you do your own project, you want all your Internet of Things just inside your house. You do not want your light bulb to be controlled by somebody potentially is trying to harm you.
Yeah, you could get hacked.
Yes, or if even the company is not doing it, the company server can be hacked.
Right.
And then this guy hacking the server start having fun to turn your
Maybe
garage door
or you
open.
turn on your security camera too, they can watch you.
Yes, they can do anything.
So the Raspberry Pi is the server then?
The server can be any computer. All you need is to install the server on a computer. Can be a $1 computer, can do a server too.
Wow.
Oh, okay.
Yeah, this is the demo I did. I installed the server on my Raspberry Pi.
And so you've been using it then to control your stuff?
Yes, I can just, for example, last year I used this MQTT. So the door sensors will send the MQTT message, and then I will use Node-RED to read the message and to see my door is open and closed.
How do you install the server on like that device that you have there?
This $1 computer?
Yeah.
It depends on what type of a system you put it. Suppose you put, they have just like a Raspberry Pi, they have 10 different operating systems. This little computer have 10 different kind of environment you can install. And then you can download the right version of server in that environment.
Okay.
Will that version be ever outdated eventually?
There's a Google one, There's an open platform one. There's so many, just like Raspberry Pi. It's a huge community.
So you can always like update it then?
Yes, that's because right now I haven't rewrite this thing. I opened it up. The problem with this is the little computer module is not recognizable. I do not recognize all the pins. So I don't know which, I only need to recognize four pins, but I don't know where they are, so I didn't able to program it. If I recognize those 4 pins, I can just solder 4 wires and connect it to my whatever computer I want to program this in, even connect to a Raspberry Pi to program this in. After it's reprogrammed, it will be good. But right now, it's not reprogrammed. If you look at the internet, if you Google smart outlet hacking. Let me Google it for you. Smart outlet hacking. Hacking is my favorite word, right? So they have tons of those. How to, if you want to do this, you buy the smart outlet, the brand they use, the identical brand. Usually on eBay, it's like a $3, $5 one. So you buy one of those, you follow their step, that will be good. But my brand is a Sam's Club brand. It's so yeah.
How do you connect that thing to the Wi-Fi?
There's an app for it usually when you buy it.
There's a push button. You hold it for 3 seconds or something like yeah. You can connect these things to the Wi-Fi. You are right, Jeremy. Combined with a cell phone app.
Yeah, Because
Yeah, you have to combine with cell phone app. You download the cell phone hack a day. This is my favorite, maybe. You just do the hack. This guy. This is a. Yeah, you just reprogram. That's the computer I'm talking about.
Okay.
So you reprogram this computer and install whatever system you want to install. There are 10 different choices. And then you install the MQTT server or client, and then you're good to go. So that's the plug. If you want to hack, you buy the same model, same brand. It will be much easier because everything inside is good. But to make sure follow safety, because the other side is high voltage. So when you do the hacking, unplug it.
So that device that you have is a server. So
Lisa?
yeah, right.
This right now is just
Just a smart plug.
Yeah, just smart plug. These things generally do not act as server, just act as client to post a message.
Oh, right.
Or receive a message.
Because I think I have this smart plug. It's called a Wemo Smart Switch, and so I guess I think I remembered where I plugged in like a lamp to it, and then like when I download the app, I could control the lamp to be on and off. You know.
Yeah, but that is through a server outside your house.
Oh.
That app is your this thing not talking to your cell phone directly. They talk to a server.
Okay.
Outside your house, and then your cell phone app get the message from that server.
Which you don't want.
You don't want that traffic. Leave your cell phone to the server outside your house, then back to your switches.
Oh, okay. Yes. Yeah. We're not using it anymore now.
Yeah. But usually it works pretty good. Yeah, it works. Yeah. But actually, you do not want that traffic. You just want your cell phone talk to that directly.
Right.
Through a MQTT server, which can be a Raspberry Pi, can be this computer. I think you can download it on your laptop too, or whatever computer you have at your home as a server, MQTT server.
Oh, okay.
Because laptop generally need a lot of power, so most good idea is use a small computer like a Raspberry Pi who need a little power. You can just plug in 24 hours a day.
Right.
So a Raspberry Pi is a pretty good candidate for MQTT server. They don't even call it a server because a server generally means a very complicated program. They call it a broker, MQTT broker. But MQTT broker is the guy who handles all the tweet.
Yeah, there's videos on it on YouTube I just found.
Yeah, MQTT is wonderful. Try it. All right. Anything else? Let's.
That's it.
That's it.
All right. Very good. I hope you guys do an MQTT. And
although that one from that website wasn't $1, it was like $30.
Look for the $1 one.
All right.
Usually it takes maybe a month to get it, but if you can wait.
Yeah, that's the robot thing that I'm doing for my Raspberry Pi. I could have ordered all the parts separate through AliExpress, but they weren't going to get here until like the middle of November, and I'm like, I can't wait that long.
You are right at it. AliExpress. AliExpress is Alibaba is the company. They have like millions of small businesses doing business on that platform. The Chinese version called Alibaba, that's inside China. The international version is called AliExpress. And AliExpress sell stuff for small business both inside and outside China. So small business here can sell stuff internationally through AliExpress. Chinese small business can sell stuff too internationally through AliExpress. And a lot of the merchandise, they have storage utilities inside the United States or Europe. A lot of AliExpress stuff can get it within days. Not you don't have to wait for a month, but some you have to wait for a month because it's shipped from China.
Yeah.
But a lot of things actually shipped from, for example, California because they have large volumes. So they actually shipped it to a storage place inside the United States.
Right.
Yeah. Yeah, there are a lot of good things you can buy from AliExpress. This is a little computer, $1 one. $3 right here. Keep looking. You will see the $1.
So it's ESP 8266 is what we need.
66 or 65. 65 is better. 65 has built-in flash memory.
Oh, okay.
So 65 is better because you don't have the external. Actually, the card you buy doesn't make any differences because the little computer you buy, if it don't have flash, it will have a separate flash memory chip.
Oh, okay.
Yeah,
right.
it's $1 anyway, so you know. Yeah, I think you have to really searching for that $1 deal. I saw it last year when I'm teaching. That's $1, 19. Did you see the $1? 174.
Yeah.
That is
probably you can get them for $1 if you buy like 50 of them.
Yeah, how about you guys just put together $50 and buy 50? Yeah, you see here, $9.
79 cents.
79 cents. My God, it's AliExpress. Free shipping.
How long will it take?
Free shipping. I don't know. That's
There's
your interest.
another one on there too for 80 cents.
Oh man.
I will buy those for 79 cents. It looks like you need volumes.
This is 30 to 50 days.
Where is that? 30, 50 days?
Because it's international.
Yeah. It's shipped from international shipping.
But you said we could also solder it ourselves, but it would cost more.
No, it's actually you don't want to solder yourself. The solder yourself thing is because you want to hack one of those.
Yeah.
You need to solder some programming wires. But this thing, the programming wire is already there. This thing is wonderful. They program through USB.
Oh,
so
nice.
There's no solder. So you just plug in USB, you program this. And that's the Wi-Fi antenna.
Oh.
So every one of these little computers can control actually almost a dozen devices. They have a dozen IOs, 11 IOs. That means you can turn 11 things on and off for one of those. Now you get the idea for Christmas lights, right? 11 Christmas lights.
Yeah.
You can have quite a show with Wi-Fi on your cell phone.
Oh.
With MQTT.
There you go.
And then put a couple motors, like Santa. Can talk, can move. Then you can have a small business, sell it to a neighbor. Actually, there are a lot of potentials. If you're doing business, you buy stuff from Ali Business volume. I know people buy truckloads of stuff and then resell it. Like the fireplace. I have a local just down the road. He makes a ton of money. Just go to China, buy a container of fireplaces, fireworks.
Oh, okay.
Yeah, and then he make a ton of money when the July 4th. And I know another couple. They just buy those stuff. Then they have a tractor trailer. They just drive that tractor trailer and sell it on the street. They travel all over United States, sell their stuff on the street, making money and then travel full time.
Yeah, I've heard stories where people can go to like the dollar store and buy a bunch of stuff for $1, and then they can sell it on Amazon for like $3 or $4 a piece.
That's correct.
Wow.
Yes, that is a lot of Amazon sellers make their money. So they have their house is stuffed with whatever on sale. They just grab it when it's on sale. And then the people are lazy. They just do a Google search on Amazon and look for like a $5. Yeah, $5. Yeah.
All right, I need to go do a chemistry test.
Well, now the business class is over, so I stopped recording. You guys start a small business after this class.
All right.
All right, see you next week.
Good luck.
All right. All right. Thanks.
Thank you.
Bye.
See ya.